Hi, let's use the physics of uniform circular motion to calculate the acceleration of the moon as it travels around Earth. Now, the moon's orbit isn't perfectly circular, but it's close to circular, and the average radius of that orbit is about 3.84 times 10 to the 8 meters. And one full trip of the moon in orbit around Earth takes 27.4 Earth days. So what does that mean for the moon's acceleration? Well, from uniform circular motion, if we know speed and we know radius, the acceleration is the speed squared divided by the radius. We have radius and we have period. Now, if we wanted to, we could calculate the speed, because if we're traveling around a circle, then our distance each period is 2 pi times the radius. Our time for that trip would be 1 period. But let's put those two equations together. So if I square my speed, I get 4 pi squared times my radius squared, divided by my period squared, and then divided by radius. So in terms of radius and period, the centripetal acceleration is 4 pi squared times the radius of the circle divided by the period of the motion squared. So our radius we have in meters. Our next step will be to take our period and convert it from days into seconds. So 1 Earth day is 24 hours. Every 1 hour is 3,600 seconds. So if I have 27.4 days, I end up with a total period of 2.367 times 10 to the 6 seconds. Now I have my radius in meters, my time in seconds. I can substitute that into my acceleration equation for the acceleration of the moon. 4 pi squared times the quantity 3.84 times 10 to the 8 meters. And then that gets divided by the quantity 2.367 times 10 to the 6 seconds squared. And working at home on a calculator, when you're dealing with scientific notation and squares in the denominator, get in the habit of putting parentheses around everything you've substituted in, because the seconds get squared to make our unit meters per second squared. The power of 10 gets squared. So our powers of 10 would be 10 to the 8 divided by 10 to the 12, and the 2.367 gets squared as well. So when you calculate out all of those numbers, we end up with an acceleration of 0.00270 meters per second squared, which happens to be roughly 3,600 times smaller than the free fall acceleration of an object here on Earth. It also turns out that the radius of the moon's orbit is about 60 times farther away than the surface of Earth is from the center of Earth. So what Newton did when he was working out his laws of motion, took a look at this idea of centripetal motion, looking at accelerations, and looked for a pattern to see if this acceleration based on period and radius of orbit seemed to explain other things, like the planets around the sun, the moons of Jupiter around Jupiter, and from that was able to reason out his theory for how the gravity of masses interact with each other. But more on that story in a much later chapter. Thanks for watching.